Welcome to Exciting Machines. Thanks for joining us for this special report. Since the dawn of humanity, we have gazed up at the stars and wondered about our place in the cosmos. The vast distances between us and those twinkling points of light have always felt insurmountable. Yet the human spirit yearns to explore, to discover what lies beyond our pale blue dot. For centuries, interstellar travel was relegated to the realm of science fiction. We could only dream of venturing to other star systems, of encountering alien civilizations, and unraveling the mysteries of the universe. But in the 20th century, a revolution in physics opened up new possibilities. Albert Einstein's theory of relativity provided a framework for understanding the universe in a fundamentally different way. It introduced the concept of spacetime, a four-dimensional fabric that could be warped and curved by massive objects. Could we harness this warping of space-time to achieve the seemingly impossible, to travel faster than light and reach the stars within our lifetimes? The idea, once confined to the imaginations of science fiction writers, began to take on a tantalizing air of possibility. Imagine a bowling ball placed on a trampoline. The ball creates a dip, a curvature in the trampoline's surface. This is a simple analogy for how massive objects like stars and planets warp the fabric of space-time. Einstein's theory of general relativity tells us that gravity is not a force acting at a distance, but rather a consequence of this curvature. Objects in motion follow the curves of space-time, much like a marble rolling around the dip created by the bowling ball. This curvature of space-time has profound implications for our understanding of the universe. It affects the motion of planets, the bending of light around massive objects, and even the flow of time. But most importantly for our interstellar ambitions, it opens up the possibility of manipulating spacetime itself. What if, instead of traveling through spacetime, we could manipulate spacetime? What if we could create our own dips and curves to propel us across vast cosmic distances? This is the fundamental idea behind warp drive. The concept of warp drive is based on the idea of distorting space-time around a spacecraft. Imagine, if you will, a surfer riding a wave. The surfer doesn't move through the water so much as he is carried along by the wave itself. Similarly, a warp drive wouldn't propel a spacecraft through space-time in the conventional sense. Instead, it would create a warp bubble around the spacecraft, compressing space-time in front of it and expanding space-time behind it. This distortion of space-time would create a wave that propels the spacecraft forward, much like the surfer riding a wave. The spacecraft itself would remain within the warp bubble, shielded from the extreme forces involved. The beauty of this concept is that it doesn't violate Einstein's theory of relativity. Nothing can travel faster than light through space-time. But what if we could warp space-time itself, creating shortcuts and bending the rules of the cosmic game? Well, we might be on the verge of doing just that. In 1994, Mexican physicist Miguel Alcubierre proposed a theoretical framework for a warp drive that has captured the imagination of scientists and science fiction enthusiasts alike. The Alcubierre Drive, as it is known, offers a mathematical model for creating a warp bubble that could, theoretically, allow for faster-than-light travel. Alcubierre's solution to Einstein's equations involves creating a region of negative energy density around the spacecraft. This negative energy density would cause space-time to contract in front of the spacecraft and expand behind it, creating the warp bubble. Imagine a flat sheet with a wrinkle in it. That wrinkle is the warp bubble, and the spacecraft rides inside. While the Alcubierre Drive is mathematically sound, it faces significant practical challenges. The most daunting of these is the requirement for exotic matter, a hypothetical form of matter with negative mass energy density. The amount of energy required to create a warp bubble, even a small one, is staggering. It would dwarf the total energy output of our Sun. And while we have observed phenomena in the universe that suggest the existence of negative energy density, such as the Casimir effect, harnessing and manipulating it on the scale required for a warp drive remains firmly in the realm of speculation. Finding or creating exotic matter is another monumental challenge. This hypothetical form of matter, if it exists, would behave very differently from the matter we interact with daily. It would repel rather than attract other forms of matter. Some theories suggest that exotic matter might be found in the quantum vacuum, the seething sea of virtual particles that pop in and out of existence at the quantum level. Others propose that it might be created through yet-to-be-discovered high-energy physics. While the challenges of warp drive are immense, the fields of quantum physics and material science offer glimmers of hope. Advances in our understanding of the universe at the smallest scales, coupled with the development of new materials with exotic properties, could hold the key to unlocking the secrets of warp drive. Quantum physics, with its mind-bending principles of superposition and entanglement, has already revolutionized our understanding of the universe. Further exploration of these principles, particularly in the context of the quantum vacuum, could potentially reveal ways to manipulate negative energy density. Material science is another crucial area of research. The development of metamaterials, which are engineered to have properties not found in nature, could lead to breakthroughs in our ability to manipulate electromagnetic fields and potentially even spacetime itself. The successful development of warp drive technology would be nothing short of revolutionary. It would usher in a new era for humanity, an era of interstellar exploration and expansion. We could reach other star systems within human lifetimes, exploring new worlds, encountering new forms of life, and unlocking the secrets of the universe. The scientific advancements that would accompany the development of warp drive would be immeasurable. It would revolutionize our understanding of physics, materials science, and energy production. The technological spin-offs would be transformative, impacting every aspect of our lives. Imagine a future where interstellar travel is commonplace, where humanity has expanded beyond our solar system, and where the mysteries of the universe are within our grasp. This is the promise of warp drive. Let us know in the comments if you think warp drive is achievable in our lifetime. Hit that like button if you found this video informative, and subscribe to our channel, as we will continue to monitor and bring updates on this and other worthy developments in the world of technology and exciting machines.